Hello folks, and welcome to my talk at Deploy 2020. I'm Erica Heidi, a technical writer at the Developer Education team, and today I will be talking about Docker Compose and how to create PHP development environments using this tool. So this talk will be divided into three parts. In the first part, I will give you an introduction about PHP development environments in general and how they changed over time and how Docker Compose fits in. And then we will see how to build a multi-container environment, how to set up a Docker Compose.yml file for that using a Laravel application as case study. And then we will have a demo at the end. So let's go for the first part. Let's get started right away. And this is a kind of a personal timeline, how I started using PHP and how things changed over time for me. So at the 2000s, this is how I started. I started working with PHP around that time more professionally, and WAMP server and XAMPP server were very popular at that time. So usually you have a Windows machine, right? And these were the options also for deploying. WSFTP was the most popular option as a deploying platform at that time. Good times. But things started to change, right? And eventually in 2010, I changed to use Linux on my working machine, and then I started using local environments to run my applications, and then this started to be a trend. Things would never work out of my machine. Things would be fine, and an extension was missing, something would be missing for sure on the remote server or on my colleague's machine. So around 2012, it's when Vagrant started to become popular, and I started using it, I think, in 2013. So the pros were that finally it was easy to share, dispose, and replicate full environments. And also the environments could be very close to what you had on the remote server finally, because you would make sure that things follow a certain sequence. But that is the problem with this, is that it depends on automation tools. So you have pretty much the same work that you would have to set up the whole automation strategy for remote server. You're now using that for your local development environment as well. So it adds a lot of extra work, and it's also working with the Vagrant VMs. Although virtual machines are easy to understand because they are kind of an old technology, they have a very big footprint, so it consumes a lot of memory. And also sharing files is a bit difficult, so that there's some of the problems with that setup. Around 2014, it's when containers and Docker started to become popular. And finally, we had something that was very fast and lightweight to run development environments. It also, the other good thing is that it would eliminate the need for heavy automation. You would not be using that much tools like Ansible, Puppet, Chef anymore, because the way that images work, it's kind of like layers that add on top of each other to build your Docker image. So you don't need to automate everything all the time, to set up the full environment. The problems were because the technology was quite new, so it was not as intuitive as virtual machines at that time especially. And also to define and manage multiple microservices, it would be very difficult. Because it would require a lot of different moving parts to get together, a lot of different commands. And to coordinate all that, just to run your development environment, it was a lot of work. So that's when Docker Compose comes in. Docker Compose is a tool that facilitates running multi-container environments. And this is all based on definitions from a YAML file. So you have a bunch of service definitions, and this will turn into a fully customizable environment. It can share networks and data volumes, and so you can build however you want it. It is quite easy to understand, to set up and manage, because it's just one file and you have all the services there. It's a lot more easy to manage than running individual commands with Docker. And you can even run multiple environments at the same time on the same host, because it's very lightweight. One good thing also is that it preserves volume data. So if you are working on something, you can just pause or stop the execution and come back to it later. So you're not going to lose all your data, only if you want to destroy it. But it will preserve, for instance, your database volume. Also, it allows you to customize a lot of things using variables. You can also inject variables to build custom images with a Docker file. You can also use environment variables to set up things. So it's very extendable and customizable. This is an example of a basic Docker compose.yml file, and this is going to set up an Nginx container, a service running Nginx. It starts with the version definition. In this case, it's using version 3.7 of the Docker Compose syntax. It has then we have the services node. This is where your services will be defined, and in this case we have only one service, which is called web. We will reference this name if you want to run commands or some things specifically on that service. This service is going to use a default Nginx image from Docker Hub, and we have also a port redirection here, which is important so that you can access your application from the browser running on your host machine. So all requests on port 8000 of the host machine will be redirected to port 80 inside the container. So this is very handy for development. Right, and this is how it looks like, the output from Docker Compose app. You will gonna see pulling images from Docker Hub, and you have different layers that compose the image. And in this case, it's running on the foreground, but usually you're gonna add -d to run it on the background mode, so it's not gonna be running like this on your terminal. Okay, and these are the most common commands that you can use to manage your environment. So to control the environment, we have the app command we've seen just now. If you want to stop working for a moment, you can run the stop commands, and this is going to stop the execution for now and keep everything safe. And when you want to come back to that, you can run Docker Compose start, and then you get back right to it where you left. If you run the down command, this is going to destroy your volumes, networks, everything is going to be cleared up. Then we have monitoring and troubleshooting commands, Docker PS, Docker Compose PS. It works in a much similar way to Docker PS. However, it's focused on that specific environment. We have the Docker Compose logs command. It's going to show the logs from the services. This is also very useful. And we have top and queue. These are also commands to manage services and whatever is running on those services, on those containers. And also another important command is the exec command. This is typically used to execute commands while you are developing the application. For instance, commands to use a package manager, dependency management tool like Composer, not to confuse with Docker Compose, but PHP Composer, NPM of sorts, things like that. And in the specific case of Laravel, we also run artisan commands using Docker Compose exec. We're going to see that in the demo. Okay, so we've seen an overview of development environments in PHP and also Docker Compose, how it fits in. Now we're going to go through this more specific case study of a Laravel application and how to containerize it. So our application is a demo Laravel application called Travelist. It's basically a to-do application, more, just changed a little bit to look like places to visit or places that you've been to. Especially meaningful in these current times. So what do we need, right? So first, what do we need to run PHP? We're going to need a web server. We're going to need PHP. In this case, I'm going to use Nginx and PHP FPM. And we're also going to need MySQL for the database, for the application database. Other than that, for the Laravel application, we're going to need to install a few PHP extensions that are required by Laravel. We're going to need also the ability to run Composer and artisan commands inside the containers. So how that translates into containers and images. We're going to need 3 different services: Nginx, MySQL, and app, which will be the PHP container. The Nginx and the MySQL both will be using a pre-built image from Docker Hub. We don't need to customize anything. But for the application, we're going to need to create a custom Docker file to create an image that has Composer on it, that has also the extensions we need. Okay, in terms of volumes and networks, we're going to need to share some files. So the application files need to go both on the app container and on the Nginx container, because you're going to need to run PHP, Composer, and artisan commands, and going to need the files to be there on the PHP container, which is called app. And also on the Nginx container, because it's where the application is served. We're also going to need to share the Nginx configuration file and the MySQL database dump to set up and get our environment up and running quickly. This is a feature from the MySQL image, but also since you are using Laravel, since this is a Laravel application, you could also just use database migrations. But that is just so we can see how it works with the MySQL image. And then we have the networks. So all containers will share the same network. Okay, this is all we need. Let's set up these services now with the docker compose.yml file. We will start with the app service, and we start with the build directive telling Docker Compose that we want to build a custom Docker image, which is going to be based on the provided Docker file using the context of the current directory. Then we're going to set the name for this image. It's going to be called Travelist. We set a container name for this container. And we tell Docker Compose that we want this service to be restarted if something happens. Unless you manually stop it, it will always be restarted. We also define a working directory, var www. Then we define a volume sharing that is going to share the current application folder on the location var www inside the container. And then we tell Docker Compose that we want to use a network called Travelist, and this is going to be the same network for all the containers. That was all for the app. Container is still going to see the Docker file for that, but now the Nginx service. We're going to use a Alpine image, so we define the image name containing the tag that we want to use, that specific version of Nginx. We define the container name and also restart unless stop it. This is the same from the other service. Now we have the port redirection. Also, it's the same that we've seen in the basic example. We are redirecting our requests on port 8000 on the host to port 80 inside the container. And then we have the volumes definition. And we share the application folder inside var www in the container. And then we have the configuration file as well. This directory is on the application is included, a Docker Compose directory with Nginx and a MySQL directory, each containing the specific configuration files for those services. This could be named differently, but it's just how I found it was better. So this is also something that comes, a lot of images have their own features. So you're gonna look at Docker Hub and then you see something like create a volume share for this directory, and then you will have this feature. Or you have, like, for instance, with MySQL, you have a volume share in a specific location, and then any .sql file inside that directory will be automatically imported as a MySQL dump. We are gonna see that in a moment. So yeah, we have two volumes and the network is the same, Travelist. And this is the database service. So the database service, it starts similar to the other ones, uses an image from Docker Hub. In this case, it's using 5.7, it could be 8. I started using 8. Then what we have different here is that we have this environment section. So the environments section is used to define environment variables that will be injected into that container, into that service. So because this image has a few different features, the MySQL image also has this feature that if you define a certain environment variables, it will create a database for you. In this case, these values are coming from the .env Laravel file that we are that every Laravel application has this .env file, and so now we are pulling from there. So you just need to edit one place, which is the .env file from Laravel, and it's gonna be pulled from automatically on your setup. And then the feature I was talking about earlier, which is if you create a volume share in the Docker entry point, you need the b.d inside the container for this image. Then any .sql file inside that will be imported automatically to the database. This speeds up a lot your setting up your environment, because if you destroy it and you get it up, it's just going to be up and running very quickly. You don't need to run migrations and all the database setup tasks, you know? So this is one way to do it. And then finally, you have the networks, same network definition. And lastly, the Docker file for the application. So this Docker file is to create a custom image for our application, since we need some custom things. It starts telling Docker to use PHP 7.4 FPM as base image, and we are building from there. It sets two variables, UID and user. So these are going to be used inside the Docker file, the next slides, to create a new user on that container, and with the same name and same UID as your current host user, your current user on your host machine. And why is that? Because you will be creating files in both directions. You're going to be running some commands that will generate files inside the container. And you need a user with the same UID for that. Otherwise, you're going to run into permission issues. When the files are created there and you want to edit them on your host machine using your IDE, you might run into permission issues. So you need a user, the same UID and the same name as your current user on the host machine. So after we set these variables, we run update, apt update, and install command to install some required packages. Then we do a apt get clean, clean up, and then we install the extensions that are required by Laravel, PDO MySQL, MBString, Exif, PCNTL, BCMath, and GD. And after that, we create the user, and we use the variables that we set up in the previous slides, UID and user. And finally, we install Composer by copying the executable from the latest Composer image. So we copy that to our image, to our own image. And we set the working directory so that commands run against this service, against this image are going to run by default on var www. And we set the user also for when you run commands, they are going to be executed as this user now. So this is all the Docker file we had, and this is an overview of the directory tree, excluding the application files. So let's say you already have a Laravel application and you're going to containerize it, and this is what you're going to add to it, Docker Compose directory with your configuration files that you have to create volumes to share within the containers. And then you have the Docker file and the Docker Compose.yml file to set up the environments. And these are located on the root folder of the application. Cool. So now finally, we've seen everything, and now we are ready to the demo time. And we're going to see now how it works, how everything works together. So this is the repository with the demo application. It's called Travelis Laravel Demo. You can find it at the DO community GitHub organization. Then you can go to the releases, and the latest release, the tutorial 4.03 release, is the one we are using here today. So you can download this to try yourself, the demo. And now we're gonna switch to the terminal. I just want to also show that there is nothing running now on my machine on port 8000. So now let's go to the terminal. And the one thing we need to do, so this is all the Laravel files and also the Docker Compose files that we've seen in the slides. And what we need to do here is create a .env file, because Docker Compose will pull from the env file to set up the database. So we need to set up this file first thing. Usually there is a .env.example that you can use to set up your .env file, and it's very basic, like just default stuff, the database information, very standard. And now that we have the .env file, we can run the environment. So we can go Docker Compose app, minus D. This will run in background mode. And now the environment should be up and running. However, we still need to run a few commands to set the application up, the Laravel application. We have to install the dependencies with Composer because we don't have a vendor folder here, so we still need to run Composer. And to run Composer inside the service, inside the container, you need to run Docker Compose exec. So Docker Compose exec app, which is the name of the service where we want to run these commands, and I'm gonna run a Composer install command. So now I'm installing the dependencies required by Laravel, by the application as a whole, and once the dependencies are installed, we might still need to run a few commands. There is the key generate command required also by Laravel. This command will generate a unique key that is used in various places of the applications, like for security, to handle forms and other things. Generates salts and things like that. This might take a little bit. It's finished now. Okay. So now we have the vendor folder. We have all the dependencies installed. But if you go to the browser now, let's just see that. No application encryption key has been specified. So that's what I was mentioning just right now. You need to run the PHP Artisan key generate commands. And we are gonna run it now, the same way we did with Composer. So we need to run Docker Compose exec app, and then the command we need to run, which is PHP Artisan key generate. Okay, so the key was set up. And now we can go to the browser again. And it's up and running. So in this case, we didn't need to run any database commands because we had imported the dump file, the MySQL dump file. And this had already the places, some bootstrap, database data, so you can start working right away. But typically you will have some migrations, database migrations, maybe some database seeds, and this will just add one or two commands to the workflow. And then you have like PHP Artisan DB migrate, and then DB seed, something like that. Can't recall right now, but you have to run, if you are using migrations, then you need to run also the migration command. But this basically, that is an artisan command, and while you are developing your application, you're gonna run a lot of these commands, artisan and composer. So you're gonna use Docker Compose exec for that. So that was pretty much it, and I hope you have enjoyed this talk. Thank you so much for watching, and see you next time.